This presentation covers Chapter 10, Ionic Bonding IGCSE Class 9 and 10 Chemistry Curriculum. This slide displays tables showing the common oxidation numbers or valencies for various ions. For metals, it lists ions with a +1 charge like sodium, Na+, a +2 charge like calcium, Ca²+, and a +3 charge like aluminium, Al³+. For nonmetals and groups of atoms, it lists ions with a -1 charge like chloride, Cl-, a -2 charge like carbonate, CO3-, and a -3 charge like phosphate, PO4-. What is a chemical bond? A chemical bond is the force that holds atoms together in a compound. There are three main types of bonds. Ionic bonds involve the transfer of electrons, as seen in sodium chloride, NaCl. Covalent bonds involve the sharing of electrons, as seen in water, H2O. Metallic bonds involve a pool of delocalized electrons, as seen in metals like iron Fe and copper Cu. This slide shows a simplified diagram of ionic bonding in sodium chloride, NaCl. It illustrates a sodium atom transferring its single outer electron to a chlorine atom. This results in the formation of a positive sodium ion, Na+, and a negative chloride ion, Cl-. What is ionic bonding? Ionic bonding is defined as the electrostatic attraction between positively and negatively charged ions. It typically occurs between metals, which tend to lose electrons, and nonmetals, which tend to gain electrons. The key concept involves two steps. First, the formation of ions, and second, the electrostatic attraction between them. For example, a sodium atom, Na, loses an electron to become a sodium ion, Na+. A chlorine atom, Cl, gains an electron to become a chloride ion, Cl-. The attraction between these two ions forms the compound sodium chloride, NaCl. Electron transfer process. The process occurs in these steps. A metal atom loses one or more electrons to become a positively charged ion, called a cation. A non-metal atom gains one or more electrons to become a negatively charged ion, called an anion. The oppositely charged ions attract each other, forming an ionic bond. For example, sodium, Na, with atomic number 11 and an electron configuration of 2, 8, 1, loses one electron to form a sodium ion, Na+. Chlorine, Cl, with atomic number 17 and an electron configuration of 2, 8, 7, gains one electron to form a chloride ion, Cl-. Properties of ionic compounds. This slide compares the general properties of ionic and covalent compounds. Melting point. Ionic compounds generally have high melting points, while covalent compounds have low ones. Electrical conductivity. Ionic compounds can conduct electricity when molten or dissolved in water, but covalent compounds do not. Solubility. Ionic compounds are often soluble in water, while covalent compounds are typically soluble in organic solvents. Key takeaways. Here is a summary of ionic bonding. Ionic bonds involve the transfer of electrons. They are formed between metals and nonmetals. The process results in stable ions held together by strong electrostatic forces. Key features of ionic compounds include high melting points, electrical conductivity when molten or in solution, and a brittle nature. Thank you for learning with us.